basically this field that's very generic and nothing special with Spitzer becomes like an interesting deep field with Webb.
I guess the next question is, and you had a beautiful thread on this, which I want to talk about, is how does this image compare to what we've had in the past? So you mentioned WISE, which is the
okay. So when this image was released, people that the people that were involved in making the optics work for Webb, they just chose this star because it was in a great location and the brightness was adapted for this test. But it turns out that the same field has been observed by other telescopes, and so the astronomical community is very reactive and started to like cross-match the field and find where it's at, and find some observation in the archive of other missions. To compare it with, and that's really cool.
It is really cool because we can see the comparisons between what we got. So for example, WISE, which is the Wide Field Infrared Survey Explorer. I think I've got a nice little picture.
Yeah, I think it's called NEO-WISE now, and it's actually still in operation for a couple of years.
But it's what, like what was it? I think you said it's
0.4 meter.
0.4 meter primary mirror. Yeah, and we can see the difference. If we expand this up, if the quality of the image...
So it's not exactly also the same wavelengths, like the WISE, this is a combination of a little bit more wavelengths. I think it goes from like 2 to 5 micron or something for the WISE image, and the Webb image is really at 2 point something micron. Anyway, you can really see, like, you go from like a few blobs, a few stars and a few bright galaxies. You don't even know if they are galaxies or what they are.
Yeah.
And it's almost like putting your glasses on or focusing a telescope. We are not focusing, we're just like switching from a 40 centimeter telescope to a 6.5 meter one. So, and it's not even the deepest we can get. It's just basically an image. This was done slightly longer than it was maybe needed for that test, but just for the press release. But still, it's very close to a test at this point. It was not chosen because of the galaxies.
No, the outreach stuff on this has been excellent. I mean, as I sort of alluded to, people want to see stuff as soon as possible, and I think the team and everyone involved has really gone out of their way to be really on the ball with the press releases and stuff. They've been really, really excellent from what I've seen, and everyone has been really helpful who I've contacted. The next one was kind of so if I go back in this, we had a comparison between DESI, which I guess is a ground-based telescope, right? Compared to the
I let me see if I remember Legacy. So yes, and so here the comparison is really striking. You can really see a blob. So this is a 3 or 4 meter telescope on the ground, and so it doesn't really matter the size of the telescope. Here you're limited by the atmosphere of the Earth.
Yeah.
So there is what we call seeing, which is depending on the quality of the astronomical site you're going to. So the best site have around 1 arcsecond resolution, sometimes 0.5, sometimes 1.5, but it's about 1 arcsecond. And so the Webb resolution is about 0.07 arcsecond. So you can see and also the sensitivity in space is much better. You don't have the atmosphere in the way, and it's very stable. So you can already see, like the improvement, something that you barely detect and something that you can already see structures. And so, for example, the top one, you can see there's actually 2 galaxies that might be mergers or something, or maybe one the other, I don't know. So it's pretty cool.
That's it. That's incredibly cool. And then the next one we had in this sort of thread. So you sort of brought them all together, which is in a really nice little thread, which I'll make sure all the links are in the description. The next one was I believe it's the Sloan Digital Sky Survey,
Yeah, so the Sloan, I think that's the image that you open when you look for the star. When I send you the link of the star,
Yes.
on Simbad, that's basically some kind of catalog of stars that we use astronomers to to know something about a star. We just typed its name in Simbad. So that's also a survey telescope on the ground. So a survey means it's basically covering most of the sky. And those telescopes are incredible to actually make catalogs and things. We all use their measurements and photometry. So, and here you can see practically there's nothing in the Sloan field. It's not sensitive enough to observe much more than the star, the one on the left, and maybe a few more in the back, and that's it.
Yeah. And then when we go to the JWST image, all of this extra detail in the background suddenly pops out in the same box. So we can look at the white box here. There's hardly anything in it, like you say, maybe a galaxy at the top, couple of stars. You whiz over to the JWST and suddenly it's completely rammed full of new things that we haven't seen before. So that's an incredible.
I just want to shoot out like a hello to Grant Tremblay that made this comparison. The one before it was made by Kevin Heinlein, who's a colleague at Arizona on NIRCam.
Yeah.
And then I think maybe one of the best ones is the one with Spitzer made by Gabe Brammer.
That's right. So there's one.
Gabe was a colleague. He used to work here also at the Space Telescope, and now he's in Denmark. And so what he did here, he quickly so he converted the image from a JPEG to a format that's easier for astronomers to use. Then he actually identified all the sources and sort of made a quick calibration of what the astrometry is. And then he found the field with Spitzer and basically made a cross, how you call that? Like when you transition from one to another.
Yeah.
So here, Spitzer was already pretty sensitive. You can see that Spitzer at 3.6 micron. So it's a little bit higher wavelength, so a little bit more infrared than ours. It is already detecting a lot of objects, but you can't really say what they are. You see like blobs. And going to Webb.
We're putting the glasses on again.
Sorry?
We're putting the glasses on again.
Yeah, so it like basically this field that's very generic and nothing special with Spitzer becomes like an interesting deep field with Webb and gorgeous, So and by the way, the Spitzer star already has 6 spikes, and that's also because in this case, it's a round telescope, but it has a telescope spider with a Y shape, and that's why you have 6 spikes.
Okay, so even in the Spitzer image, when it comes to the blob, you can see the spikes out of the side still in the. That makes sense. Even though it's a round telescope. And Spitzer was a telescope that was an infrared telescope in space, right? Is that correct? Or
yes. So for a long time, up to now, that's the most sensitive infrared telescope, at least in those wavelengths that we're talking about, that was available. And I think it stopped. It was active for more than 15 years ago, but it stopped a few years ago. And a lot of colleagues that worked on Spitzer are working on Webb. And
this is what always happens in particle physics, right? They go from the LHC to Fermilab, and then they come back and they go to the next experiment. So that's
I mean, by the way, like people talk about the how much Webb, was about $10 billion worth was spent basically to make it. But it's about 10,000 people that worked at some point on Webb. It's a lot. And at a single moment, it's probably a couple thousand, at least 700.
I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.